Okay, so today we're going to be using quadratics to find very specific things with word problems, your favorite. Basically, though, there are three main things that you find when you are doing a word problem. So before I tell you what those three things are, I want to give you a word problem and kind of show you what I'm talking about. So take a look at my Angry Bird. Do you remember the game Angry Birds? I don't know if this is what he looks like, but close enough. So he is going to be projectile shot, right, somewhere. And this is a quadratic or a parabolic shape, okay? So there's a couple of things that you can find. One of the things that, that you can find is you can say, okay, when will he hit the ground, right? So when will he land? So keeping in mind, this is time on the x-axis. On the y-axis, well, let's think about that for a second and think about what that's going to represent. So when is he going to land? So that's one of the things that you can find, right? When something hits the ground. Now, maybe we are talking about a golfer. And so here's a guy with a golf club and a golf ball, right? And he's going to hit the ball. Maybe he's hitting a sand wedge, right? How long is it going to be in the air? And so you're trying to find this time. Now, what does this represent on the x and y axis on a parabola? What does this represent where it crosses the x-axis? I'm hoping that you just said in your head a 0, right? And so you're finding a 0, okay? Maybe I want to know, hey, here's my Angry Bird. How high is he going to fly? Here's my golfer. How high is the ball going to go, right? And so maybe that's something that you're going to find. Well, what does that represent? What is that called? Do you remember what that's called in a parabola? It's the maximum height. Starts with the letter V. Yeah, I'm hoping that you said vertex, right? So if I wanted to know just how high it went, do I want to know what time it made its highest? Or do I want to know the actual distance? And so usually that's what is on the y-axis. So if you want to find how high it is, then you want to know what the y coordinate is at the vertex. Sometimes you want to know, though, when it's going to reach the maximum height. And so sometimes you want to know this value. Here's my Angry Bird. When is he going to hit the maximum value? What's that bird that when he flies, you click it and he like zoom, 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 right? Goes off in different directions. I can't remember what that Angry Bird looked like, but sometimes you want to know when that is. And so sometimes you want to know the vertex, but you want to know the x coordinate at the vertex. And so that's what we're going to practice right now, just for a little bit. All right, so let's practice a little bit. Here is a problem, okay? Jack wants to know how high the soccer ball will get if he kicks it straight up in the air. So I want to know, what are we looking for? Do we want the x at the vertex, the y at the vertex, or the positive 0? We're going to talk about this when we do a couple practice problems. So we've got a soccer ball, right? Oh, Furkan is going to kill me because I don't know how to draw a soccer ball, right? But we have a soccer ball. We're going to kick it, and he wants to know how high it will get when he kicks the ball. So how high is it going to be? Is that going to be an x or a y? Definitely it's going to be a y, and it's going to be at the vertex. Okay, let's try another one. Lily wants to know how long her toy rocket will be in the air after she lights the fuse to launch it. And so here's our rocket ship, right? And it's going to like, yeah, go up in the air. How long will it be in the air? So it's in the air here, in the air, it's coming back down, and then it crashes and dies, right? And so what is this? Is this the x at the vertex, the y at the vertex, or the positive 0? Definitely the positive 0, okay? All right, let's try one more. What about this one? Nancy is trying to find out how many seconds it will take the golf ball to get at the highest point. So here's Nancy. Okay, look, I drew her with a little skirt on. She's not wearing a shirt. Let's put a shirt on her. Crazy Miss Hunsaker, really? Okay, here's Nancy with her ponytail, okay. How many seconds will it take to get to the highest point? Well, the highest point is the vertex, and do we want the X or do we want the Y? And so I'm hoping that you said X-axis. All right, let's go try some real problems. All right, so typically this would be a scavenger hunt, and so this would be printed on, each word problem would be printed on one page and then put around the room, and you would have to go find an answer. So there's a really good chance that the answers are in order, and that's okay. As long as you have the work to back it up, I don't care, okay? Keep in mind, right, no work means no credit. Okay, and the other thing that I want you to keep in mind is that this particular paper right here is just if you want it. So you are welcome to use your own notebook paper. It does not matter, okay? The first problem that we're going to do together is Maria's problem. So we just kind of spent a couple minutes talking about, well, what is it that we're trying to find, right? The X at the vertex. Maybe we were finding the Y at the vertex. Well, how do you do that? So let's talk about that. Okay, so the first one that we're going to do is Maria. This is her equation, and I'm going to go write it down. So on my paper, if you're using this one, okay, Maria's equation is negative 16t squared plus 18t plus 5. And I want to know for Maria, okay, she's jumping on a trampoline, what is the maximum height that Maria will reach? So here's Maria, okay, she's going to jump up and come down. What is the maximum that she's going to do? The maximum, and this says height. So do we want the, we definitely want the vertex, but do we want the X or the Y at the vertex? How high is she going to go? So I'm hoping that you just said X. Or I'm sorry, Y, right? But how do you find that? Do you remember how to find that? How do you find that? So the vertex equation is X equals negative B over 2A. That's going to give you the X. Okay, so let's go do that. So X equals, I need the opposite of B, so I'm going to do negative 18 over 2 times A, so 2 times negative 16. I'm going to get my handy dandy calculator. You're probably using your phone or something similar, which is totally fine. Just be careful when you do this that you're going to do negative 18 divided by, you have to type this into your calculator correctly. And so if you need to go type in negative 32, then type in negative 32 because that's what 2 times negative 16 is. If you have a fancy calculator like mine, if you do not put the denominator in parentheses, like I just did, you're going to get a different answer. So check this out. If I did negative 18 divided by 2 times negative 16, I get 144, and that is not correct. She is not going to be in the air for 144 seconds, okay? So kind of keep that in mind. You have to be smarter than your calculator and type it in correctly. So make sure you put your denominator in parentheses or just figure out what your denominator is and go type it in. Okay, so we got X to be 5625. Well, that's great, Miss Hunsaker, but how do we find the Y? How do I know how tall or how high she just jumped in the air? Well, if I know that at 0.5625 seconds she was at her height, I can go back in here to my equation and I can go type that in. So my X represents time. And so I'm going to go put that into my equation where the T is. So to find Y, we're going to do negative 16 times 0.5625 squared plus 18 times 0.5625, and then we're going to add 5, okay? So let's go type all of that in. So negative 16.5625 squared, Okay, if you need to do these separately and write them down separately, then do that. Otherwise, if you have a fancy calculator like mine, you should be able to type it all straight in. I'm going to do it separately just because. And then plus 5. So negative 5.0625 plus 10.125 plus 5 gives me 10.0625. That's how high she jumped. Okay, so she jumped about 10 feet. Okay, so 10.056, and it does. It looks like I'm at the next one. Oh, thank goodness that's what I got, right? All right, let's go try the next one. So now we have Rob dropping a hammer. So my next one is going to be, the equation is about Rob. Okay, and his equation says negative 16t squared plus 20. Let's read what Rob does. While working on a roof, Rob dropped his hammer. Oh no, the hammer's fall can be represented by this equation. T is time in seconds, H is height in feet. How long will it take the hammer to reach the ground? So, Rob is up on a roof, here he is, and he drops a hammer, right? How long will it take for it to hit the ground? So are we finding an X at a vertex, a Y at a vertex, or a positive 0? So I hope you said we're finding a positive 0. Okay? All right, well, how do you do that? How do you find a 0, Ms. Hunziker? All right, well, quadratic formula, right? Set this equal to 0. Negative 16t squared plus 20 equals 0. All right, well, let's see. Quadratic formula, negative b. Negative b? What's b? How do I find b? Right, what's the b number? Do you know what the b number is in here? Remember, the b number should be the number with just the variable, and it looks like this one doesn't have one. Okay, so I'm going to do 0, because that's what b is, plus or minus. 0 minus 4 times a is negative 16 and c is 20. And I'm going to divide by 2 times a, which is negative 16. Okay, let's get the calculator and get to work. All right, so 4 times 16 times 20 is 1280. And it looks like I have a minus and a minus. So I'm going to end up with 0 plus 1280. Well, now I have to square root that number, right? So let's do the square root of that, and we get 35.77. So we have, I'm going to scooch up here, 0 plus 35.77 divided by negative 32, and we have 0 minus 35.77 divided by negative 32. Again, you got to be smarter than your calculator, right? Make sure that you do the numerator and then divide it by the denominator. Well, look, what just happened? I just got a negative number. Hang on a minute. Let's come back to that. Let's go finish. 35.77. I'm subtracting this time, and I'm going to divide this one by negative 32, and now I get a positive answer. Oh, yep, I want a positive 0. So here's Rob. When time is at 0, he's already in the air. And so this parabola, if I use symmetry, it would hit the ground back here, back in time. But back in time doesn't make sense. We haven't built the time machine yet. Okay, not yet. I know, some of you are close. All right, so there we go. So at 1.12 seconds is what we end up with. And check that out. That's the next problem. Oh, thank goodness. Okay? All right, I'm going to do one more problem with you, and I'll show you which one I'm going to do. So the next problem that I wanted to talk to you about, and I wanted to skip one was actually Sean. The Sean tossing the coin off of the bridge. Notice how I draw a picture with each one that I'm doing. Please make sure that you do that. It's definitely going to help. This one wants to know how long it will take the coin to reach the stream. So you're going to do quadratic formula.